Two users edit the same database row at the same instant. One change is about to vanish silently unless the database has already picked a strategy to stop that. Say Alice and Bob both load an account balance of $100 and both plan to update it. If nothing coordinates them, whoever commits second simply overwrites whoever committed first, and that first change vanishes with no error, no warning, nothing. This is called a lost update, and it is one of the oldest problems in concurrent systems. There are exactly two mainstream strategies for preventing it, and they sit at opposite philosophical extremes. One assumes conflict is common and prevents it up front. The other assumes conflict is rare and only deals with it if it actually happens. Understanding both and when to reach for each is the difference between a database that quietly corrupts data under load and one that scales gracefully. Pessimistic locking takes the blunt, safe approach. Block first, ask questions never. The moment Alice's transaction reads the row she intends to change, she takes out a row-level lock, typically with a statement like select for update. That lock is held until her transaction commits. If Bob's transaction tries to read or write that same row while Alice holds the lock, Bob simply waits however long that takes. Once Alice commits, the lock releases and Bob proceeds safely with fresh data. Nothing can slip through because the database physically prevents two transactions from touching the same row at once. The trade-off is throughput. Every blocked transaction ties up a database connection and adds latency, and under heavy contention on the same rows, queues can build up fast. Optimistic locking flips the assumption entirely. Assume no conflict and only check at the very end. Alice reads the balance along with a version number, say version 1, and takes no lock at all. Bob can read that same row in parallel, no waiting required. When Alice writes, her update statement includes a condition, something like where id equals this row and version equals 1. If no one else has touched the row, that update succeeds and the version increments to 2. But if Bob already committed a change first, that same where clause on Alice's update now matches 0 rows because the version has already moved on. Alice's transaction sees 0 rows affected, detects the conflict, and retries against fresh data. Nothing is ever blocked. A collision just costs a wasted write and one retry. Put the two side by side and the difference is really about where the cost lives. Pessimistic locking pays its cost up front in waiting for a guarantee that nothing ever collides. Optimistic locking pays its cost only when a collision actually happens in the form of a discarded write and a retry. Pessimistic scales worse as contention rises because lock queues grow. Optimistic scales worse as contention rises too, but differently because retries pile up instead of waits. Pessimistic also introduces a real risk that optimistic never does, deadlock, where two transactions each hold a lock the other one needs, and the database has to detect and break the standoff. Optimistic locking simply never holds anything long enough for that to happen. So which one should you actually reach for? Pick pessimistic locking when many transactions genuinely fight over the same rows, like a flash sale hammering one product's inventory count, or when the cost of a conflict slipping through would be severe, like a financial ledger. Pick optimistic locking when reads vastly outnumber writes and collisions are naturally rare, like two people editing a shared document minutes apart or a user updating their own profile. As a simple rule of thumb, if contention is the exception, optimistic wins on throughput. If contention is the norm, pessimistic wins on sanity. Both strategies solve the exact same lost update problem, they just sit at opposite ends of the same trade-off. Pessimistic locking says lock before you touch it, block instead of colliding, and pay that waiting cost up front for an ironclad guarantee. Optimistic locking says read freely, check only on write, and pay the cost later as a discarded write and a quick retry. Either one is universally better, and reaching for the wrong one is a common performance mistake. Forcing heavy locks onto a low contention workload just adds needless waiting, while trusting optimistic retries on a hot, contested row can spiral into wasted work under load. The right choice always comes down to one question: how often do two people actually show up at the same row at the same time? Thanks for watching.